Welcome to 15.2 Solutions Written as Square Roots. We are going to solve each equation and we're going to use the plus or minus notation when it's appropriate. All right, this first equation, we want to get, in order to use square roots, we want to get the x squared, whatever is being squared, we want to get that by itself. So our first step is going to be moving this negative 13. And we're going to undo the negative 13 by adding 13 to both sides. So what's left is x squared equals a positive 1. And if I take the square root of both sides, in the past we were just asking ourselves, what squared is 1? Well, we know 1 squared is 1. We also know that negative 1 squared is 1. So we were thinking about it rationally, but what I'm going to say now is, what if we took the square root of both sides? So the square and the square root undo each other, and we get the square root of 1 is plus or minus 1. So we're going to use this notation instead of doing it as two separate. We're going to write it together. All right, let's try this. So our first question is the quantity squared all by itself on one side, or are there extra things that we need to deal with? Some people might want to add 6 to both sides, but you need to think about this as being kind of locked inside the square. We can't undo that minus 6 by adding 6 until we've already dealt with that squared. So our very first step here is going to be to take the square root of both sides. What is the square root of 0? Square root of 0. What times what gives me 0? Well, the only answer is 0. We don't have a plus or minus 0. That doesn't really make any sense. So here the square and square root undo each other, and x minus 6 is there. We have one last step to add 6. Now that 6 we can access, and we get x equals positive 6. And there's only one solution. So if I was graphing this, I would think, well, let's see, it moves 6 to the right. So there was just one solution because it hit at x equals 6 and it bounced off, right? That would be the equation. So it's just one solution. All right, now this one is a little more exciting. If I get x squared by itself and I subtract 9 from both sides, I've got my square by itself. And then if I try to take the square root of both sides, I say, okay, well, square and square root cancel out, and x equals, wait a second, the square root of negative 9. What value times what value, if they're the same exact value, are going to equal a negative 9? Well, if I tried 3 times 3, that would equal positive 9. If I try negative 3 times negative 3, that equals positive 9. And I can't do 1 plus and 1 minus, so we do not have the tools yet to solve that. So we're going to say there's no solution. And technically, it's no real solution. But we are not exploring imaginary numbers yet. So there's no solution in that case. If I was to graph that, right, it says x squared plus 9. Here's my parabola. Oh, that should be more symmetric. Sorry. Let's try one more time. It's still a little off, but that's okay. It never crosses the x-axis. My graph doesn't have any solutions. All right. Here are 3 more for you to try. So I'd like you to hit pause. Try to solve these. You want to use your plus or minus when you take the square root of both sides, and you can take the square root. We don't need it with 0. And then come back and we will talk about it. Notice we've got x squared plus 1, and x plus 1 squared. So it's very similar, but all 3 have different answers. So be careful. All right, take a minute and pause. Great, you should have already tried these problems. So if I take the square root of both sides, we get x equals plus or minus the square root of 18. On this one, we first need to take 1 away. X squared equals 17. Now, if I take the square root of both sides there, x equals plus or minus root 17. Now here, technically, square root of 18 can be simplified. If you break it down, it could be 9 times 2, square root of 9 is 3, so 3 root 2. Some of your teachers may have shown you that. It's a good skill to have for the SAT. So let's review real quick. The square root of 18, if we say, oh, well, 18 is really just 9 times 2. So I can break that down like a factor tree. And, well, the square root of 9 is 3, and square root of 2 stays under there. So I just simplified from square root of 18 to 3 root 2. It's just another way of expressing the same number. Okay, now this one already has the something squared, the quantity squared, all by itself, isolated. So we're going to square root both sides. We're going to cancel out that square. Let's not put the parenthesis. I don't need the parenthesis anymore. X plus 1 equals plus or minus the square root of 18, right? Because there's two ways to get that. All right, and then last step, subtract 1 from both sides. We tend to put the negative 1 in front. So if I subtract 1 here and subtract 1 there, we tend to put it in front of the plus or minus symbol. Technically, plus or minus root 18 minus 1 is the same amount, but for clarity, we don't want that negative 1 to look like it's underneath the radical. So we tend to write it out in front, like that. All right, I hope this video was helpful in using square roots.